Just wanted to talk a little bit about the presentation we went over, the slides we went over in class. Basically, the big goal is just what are geographic features, how do they affect climate? So I'm just going to follow along in the slides. I'm going to go just summarize, won't take very long, but it's going to help you with the geographic features, the data tables, and those charts that I'll put up later. But basically, things like lakes, big bodies of water, rivers, mountains can affect the climate of a region. So maybe a certain city within the United States. So example, if you look at the volcanic island that is over here, we have three cities, A, B, and C. The climate of A could be different because they're at a higher elevation, so it could be colder. C could be more precipitation because they're along the coast, maybe more stable temperatures. B is obviously being affected by the smoke plume, so less sun that day. But just even little things within the island, these three locations could have a different climate. Biggest difference between weather and climate is that weather is day to day. So it's the conditions like today, tomorrow, maybe this week when you look at a forecast. But climate is over a period of years. Typically it's 30 years. So Iowa's climate is cold in the winter, would be an example. Iowa's average temperature in December is, let's say, 35 degrees for a high. That's climate. But we know, for example, we can get a 60-degree day randomly. That'd be weather. Okay. With the activity that you guys are going to be doing, we did this in class. But we're going to be looking at what are called climatograms. The big thing is just being able to read them. So you can see this is all the months. This isn't for one particular year. This would be like the average precipitations for several years of data. And this is in millimeters. And then here's the average temperatures throughout those months. So you can see Washington, D.C.'s hottest average month is in July at 27 degrees Celsius. You can see their coldest average month is going to be in January, which makes sense. And then you can see the precipitation down here with their highest month being 101.3 millimeters. A couple other things we talked about is just how this term prevailing winds is going to be important. It says it's the direction with which the wind usually blows. So like Iowa, we have westerly winds. So that would mean the wind typically comes from the west, but we know it can come from lots of different directions too. Here's an example of how climate, if this was a big lake, so like the Great Lakes or maybe oceans, if there was a city on this side, on the leeward side, that city actually could get more precipitation than a city on the windward side because the air mass or the wind is going to blow over the big body of water, pick up moisture, and then maybe dump it here, okay? So that'd be an example of two cities on the opposite sides of a huge lake like Lake Michigan. Something like that could actually have different regional climates. I'm going to buzz through these. I'm just going to say them. We had these filled out, but in this example, St. Louis is inland, San Francisco is coastal, and you can see that this is temperature, and these would be those average temps throughout the year. You can see that St. Louis has a big range, gets really cold in the winter, really hot in the summer, and that's because it's inland. It's surrounded by lots of land, and land just changes temperatures quickly. And then San Francisco, you can see, is pretty flat, meaning the temperature is pretty stable, and that's actually because they're along water. Water is very good at just maintaining temp. So that's kind of a rule. Inland, you may have a fluctuation in temperatures, and coastal is going to be more stable. This example, exact opposite. So we could just say that coastal is more stable, maybe more precipitation because of the water, but the temperatures might hang around a certain spot. Really hard fast rule is that higher in elevation, the colder the average temperatures. So example would be like Denver, Colorado is typically going to be somewhat cooler all year long compared to Iowa. But not every day. There's always exceptions to that. Or we could say that Vail, Colorado, which is higher in elevation compared to Denver, would be colder. This one, it's called a rain shadow. So think like here's the prevailing winds coming across the big body of water. This mountain can't be a hill. It's going to have to be really high elevation. Is going to force that high moisture air up vertical. And when that happens, we form clouds, get precipitation. So this side of the mountain is actually going to be green, have a lot of vegetation, where this side of the mountain, because the air is going to keep moving, we just wouldn't have much moisture. So it's going to be really dry over here. I'll show you a satellite photo. If you look at this, this is actually satellite photo of an area. Oops, I want to move on here. Yes, this one. So you can see this is Mount Hood. This is out in Oregon. So the winds are blowing from left to right across this part of the United States. This would be the high elevation. So the ocean, we could say, would be over here. Winds blow across, hit these mountains forced up. So we get a lot of rain and condensation and precipitation here. But then on the other side of the mountain, which would be called the the leeward side, this is basically desert. So a region, same close, definitely different regional climates. Okay. So that's that. Big ideas in a nutshell. And this will help you with the regional climate activity that's in Google Classroom, which I'll make a different video for that. And